This is lesson 5 about the speed of sound. This is an experiment that we do in the lab to show you how to calculate the speed of sound. So you have two microphones. Microphone A, they're calling it here. If you make a sound like a clap here, then the sound causes a timer to start. The sound travels down through the air. When it reaches microphone B, it causes the timer to stop. So when we did this experiment, we measured the distance between the speakers and we wrote down the time it took for the sound to have travelled from microphone A to microphone B. That time that we got was 0.012 seconds and the distance between the two microphones was 4 metres. So to calculate the speed of the sound, speed is distance over time, and that's equal to 4 over 0.012, and that gives you an answer of 333 1/3 metres per second. Now, at 20 degrees C, it depends on the book that you look at, but at 20 degrees C, they suggest that the speed of sound is about 340 metres per second. So that's a very reasonable answer. If they ever ask you to do a question, they'll always give you a speed of sound to work with. So sound waves need a substance to travel through. What are all substances made of? And the answer is particles. And we know those particles are atoms and molecules. Which is a particle model of a solid, a liquid and a gas. So you can see the three, if I scan out a wee bit, you can see the three pictures there. And of course the one where the particles are densely packed together is a solid. A bit further apart and not in such a regular pattern is a liquid, and lots of space to move around in and not too many particles is a gas. So in which of these states are the particles closest together? The answer is of course a solid. And in which state are the particles furthest apart? And the answer is a gas. So that leads us to the speeds of sound in the different substances. So we know the particles are furthest apart in a gas, and that would lead us to believe then that the speed of sound is slowest in a gas, or slower in a gas than it is in a liquid, and slower in a liquid than it would be in a solid. And that's just because of the arrangement of the particles and how close they are and how densely packed they are. So we're going to take a wee guess here at some of these values. You've got 5 values and 5 different mediums they could travel through. We know the 340, we recognise it, that's air. So we can ignore it. Now, carbon dioxide is also a gas. So if you look at all the rest of the values, these are 3 big values and this is a small one, very close to that of air. So we would expect that that one there is the carbon dioxide. So that's 2 of them gone. So then we've got glass, aluminium and water, and glass and aluminium are of course solids and water is a liquid, so the liquid one will be next because it's a little bit more densely packed than a gas but not as densely packed as a solid. And then we're left with aluminium and glass, and we should know from just experience that definitely that aluminium will allow the sound to travel much more quickly, and aluminium has got a lot more densely packed molecules, and so glass we would expect to be this one, and aluminium this one. Now if you have a wee look at that value compared to that value, you can see that the speed of sound in aluminium is roughly, I'm only kind of guessing here, about 20 times greater than that in air. So you can see that does make a big difference what type of material the sound is travelling through. Breaking the sound barrier. If you break the sound barrier, you travel faster than the speed of sound in air. So you want the speed to be greater than about 340 metres per second. So you can stop the podcast and do your calculations and then check what you think. So speed is distance over time for each one. In this case it's 600 over 5. And that gives you an answer of 120 metres per second. So that's not going to break the sound barrier. A jet fighter is has got a distance of, travels a distance of 900 over a time of 2. So that's going to be 900 over 2, which gives you 450. So that one definitely is going to break the speed barrier. The next one is a cheetah, and the cheetah is travelling 500 metres in 2.5 seconds, 50 metres in 2.5 seconds. The speed is 50 divided by 2.5. That gives you an answer of 20 metres per second. And the last one then is a meteorite, and that's 10,000 divided by 0.35. So it's 10,000 divided by 0.35. And that gives you an answer of 28,571. So there's only 2 answers there which are going to break the speed of sound barrier, and they're going to be the jet fighter and the meteorite, because their values are greater than 340 metres per second.